Hello and welcome back to this video. So this video about OpenID Connect is a little bit of a continuation of a video I made in the past. But while the past video more focused on having things running in Kubernetes, this thing focuses more on having things running inside plain Docker, and it also adds the Spring Authorization server that we can leverage here. But without further ado, let's dive in. So as always, we will start with the basics. So the first thing, of course, we need is some kind of authentication provider. And I'm using Keycloak here, so we can bring up our Keycloak in Docker. There is a Docker compose file here that will just bootstrap Docker 20. So let's take a look how this looks like. So that thing is already starting. So we get a Postgres database and Keycloak. What we will see right away is that this already consumes a lot of memory, at least 500 megabytes, and also a Postgres database. If we take a look inside our Keycloak, we have to add a URL here. So this is intentional. We can log in. So super secret name admin, as you may have seen in the other video. And now we are greeted with a welcome page by Keycloak. Keycloak works like this, that we have multiple realms, or we can have multiple realms. So we see one realm tenant 0 and one tenant 5. So I select this one, and now we can take a look. So with OpenID Connect, we always need to have clients. So the client is basically the application that authenticates against the OpenID Connect provider. And of course, there's also users. So users like me, like you. And so there is only user 1 here in this example, and other stuff. And these are the most important things: realms, users, and clients. Okay, let's close that for now. So authentication provider is working. What we of course also need is an application. So I have my calling service here, my trusty caller service. I will start the application, and this application is configured to run against Keycloak. We will see that later. But let's start with some easier things. So my application is running. It's running on localhost 50,900. And if we will now try to call our application like this, not a lot will happen. We get a 401, which basically means we are not authenticated, because I did nothing to authenticate. I just called this URL. So what do we need to do? While we have now an authentication provider via OpenID Connect, the first thing that we need to do is to obtain a token, a so-called JWT, or some call it JOT. So we need a lot of mumbo jumbo here. It's basically a curl request. We need to put in the realm, the user, and also the client. So the client in this case is also OAuth proxy. And this is only a little bit done via variables, but basically this will just a curl request against the so-called token endpoint. So we will do our curl request, and let's see what will happen. Yeah, we did our curl request, and now we get an access token. With this access token, it will now be possible to call our application. But before we call our application, let's take another look here. It's important to understand the basics and the nuts and bolts. So this is a so-called JWT token, and we can decode this in the browser. So there is a website that is called jwt.io, and we can take a look what's inside the token and a little bit take a look behind the curtain. So we see a lot of configuration here, and besides the above configuration, what is also important that is we have so-called scopes in OpenID Connect. One is OpenID, and we have other scopes here. We have an email address, which will be very important later. We have a preferred username and other attributes, and all these attributes are part of this JWT. Okay, we need to hurry up a little bit because the JWT has a lease, and it will go invalid after a certain amount of time. But it should be still valid. So now with our JWT here, we are able to call our application. But of course, we have to pass in the JWT. We will do this via a header, and then we say authorization bearer and the access token we got here. And that's it. It's not a lot we see, but we now get a 200, which is of course good. And we get our your name is Heisenberg, which means everything has worked out properly. So what we did here is basically the easiest type of authentication. So this is usually if a backend calls a backend. So we have a client, which can also be a backend. It will pass in the credentials, call the OpenID token endpoint, get a response as a JWT, and then pass in the JWT into the application. The application will verify that and then return the actual object, a person or a callee nowadays. And that's basically it. And that's the simple thing. Now let's get into more interesting stuff. So having the option to call from backend is very nice. But what we usually want to do is to log in via frontend. So let's take a look. We will now log in into our application that I started earlier. So we will be prompted now with a login screen. This login screen is presented by Keycloak. We see this by this wonderful grayish background. And now we have to log in. We have to say user1, and then we are logged in, and that's already it. However, there is a lot of stuff that is going in the background here that's a little bit more complicated than just doing the backend call. Let's take a look again. I will activate my Chrome network monitor here. We will not see too much, but I will explain this. So we will again our localhost call. Then we already see that there is a lot of things going on here. And we are logged in. We don't take a look into too much details into our network monitor here. Let's go here. There is a small diagram. So what's basically happening? So if we remembered on our backend side, we provided our credentials directly, called the token endpoint, got JWT, and then we could pass in that to do our application call. On the front-end side, that's a little bit more complicated. So now, obviously, there is one more participant, which is the front-end. And now we do not pass in our credentials via a curl. We enter our credentials. So user1 and the password are entered. With these credentials, the front-end and not the back-end, that's the important part. This is why we also now have front-end URLs here. The front-end will call the OpenID Connect provider and will get a one-time code. This is not the JWT. This is, as the name implies, a so-called one-time code that can only be used once. This one-time code will go to a redirect URI of the application. And with this, now the backend of the application, not the front-end, will call the token endpoint of our OpenID Connect provider and now receive the JWT. But it's not finished. Now we have the JWT. The application knows that the authentication went fine. And now we are back at the front end. The front end will set a cookie that everything is authenticated. And now the actual call to our service works here. It looks a little bit complicated, but basically it's our backend part would start here, that we have passed in our credentials and they get JWT. And on the front end, we have this indirection that we work with this one-time code. Why do we have a one-time code here and not directly JWT? That's very simple, because the JWT is something you can use for up to 15 minutes to authenticate. And if the JWT would be somewhere inside the front end, this would be an attack vector we could use to attack our application. But as we only have this one-time code in our front end, it's much more complicated to attack our application because, as the name implies, the one-time code can only be used once. So if an attacker can obtain the one-time code, he has one try to do something and that's it. And this is because there is this is also called the authorization flow, why this is a little bit more complicated. And what's also important to know that we have front-end and back-end, and that we have front-end URLs and back-end URLs in the process. This is not a big problem if your application and your identity provider is running inside the cloud, and you will always have some, I don't know, Keycloak secretserver.org thing. But if you have a local setup, we might see this later, there might be a mixture of front-end and back-end URLs you have to take care of. So let's get back to our application and see what's going on here. So this is our application YAML, and we see that we have a lot of configuration here. So this is the configuration we need to connect to Keycloak. We need some URLs here. We need to set some endpoints here, authorization URI, token URI, and a lot of other things to get this working. As OpenID Connect, however, is a standard, we have the option to replace our identity provider. So what we will do now is basically stop our Keycloak application in Docker, and we will bring up an alternative, the so-called Spring Authorization Server. Okay, with this being running, we need to do some changes here. So we need to at least replace the base URI. Then we can bring up our application again. We'll start eventually. And now we can go to our login. So we will now be prompted with a login. As I told you, we don't have the Create background anymore. So this is not Keycloak. No, so this is now the so-called Spring Authorization Server. But from that point on, it's basically the same. We are authenticated and we can call other applications. Of course, this authentication is also single sign-on. That means that if you have several applications that run inside the same browser context, you only have to log in once. Okay, so that's fine. That works. What else can we do? So I can, again, stop my application. The question is, do we need all this configuration here? The answer is maybe. We might get rid of all of this, so replace all these endpoints, and then we will just say issuer URI. This one URL, we can restart our application, and it should hopefully work. If it starts, we will log in again. And we are logged in and everything is still working. So how can that be? Well, that's pretty simple. So if we just set this URL, there is something going in the background and there is some endpoint that is being called. That's the so-called, I have to look it up, well-known OpenID configuration, that thing. We can curl this, so that's done. And this will return all the URLs we entered before. So the application knows its endpoints. This, however, has one drawback. It will create an absolute URL and it will just return any URL you will give it. So if you do localhost, it will return localhost. If we do Kubernetes, it will just return Kubernetes. While this is the obvious solution, if you will be working with things like host.docker internal in the background that we might see later, you will run into a problem because you will have localhost in the front end and you will have this on the back end, and this could lead to a lot of confusion. But it's not only possible to replace the identity provider, we can also replace the application because it is a standard and we combine everything with everything. As I showed you in my other video, Quarkus is also working. For Quarkus, it's pretty simple. We also have to pass in this URL and it will then auto-detect via the endpoint I showed you automatically where it should go. So we start our Quarkus application. That should look pretty much as this application. We go to localhost 50,900. With Quarkus, it's a little bit different. We have to at least click one link, then we need to authenticate, and it's working. It's working the same as our Spring application. Now you might think, why all the trouble? We could always use Keycloak. Yeah, that's right, but there are two obvious differences. One is, if we say Docker stats here, this application, in contrast to Keycloak, only consumes 30 megabytes of RAM. If you remembered, Keycloak used for 500 megabytes plus a Postgres database. Second, you need to configure Keycloak every time. You need to add the realms, the users, and the clients. You can import things like that. I showed you this in my other video. But you need to configure the system every time you want to install it. Keycloak is good for production, but if you want to have something for development, our Spring authorization server can help us here. Not only has it a lot of resources less, it's also easier to configure. So let's now take a look at the Spring authorization server. I will start this once first so that we can take a look at this thing. It will start now not via Docker, but inside the IntelliJ. Open in a window, and now I just click a link here because otherwise I will run into some Google trouble. So the link is basically, it will do a localhost call and it will add some stuff here. It will pass in the client ID, a response type, redirectory. It's similar to what we did on the backend, if you remember. We can now log into our application. And we see that it works because I told it to use the redirectory, the base URL, and this works because we now see that the one-time code will be passed inside the URL. So this means that it's working. You can, however, also just open the server directly. So you can just say HTTP localhost, and it runs on this arbitrary port. Then you can also log in. This works, but this only initiates the standard Spring security process. It does not verify if OpenID Connect is working. Okay, nothing much here. You have a health endpoint and you have the discovery endpoint I showed you earlier in curl that gives all the URLs here, well-known OpenID Connect configuration. So let's stop this. So the question is, does this mean that I programmed my own Keycloak? Well, actually not. So this is something that the Spring people provide. This is so-called authorization server. So what we basically need is we need security from Spring Boot. We need this authorization server dependency, and optionally we also have the resource server dependency. So we basically need dependencies and we need some configuration as usually in Spring. What's also very nice, this can be combined with building native images. So if you want to know more about native images, you can take a look into my other videos there. But if we do Docker image native, we will also get a native image, and this is the reason why this only consumes 30 megabytes of RAM. So if we take a look at the code, we have an application class here, and we have some configuration classes here. Most of the configuration classes are taken from the example, from their website. You can take a look, Spring Authorization Server. There is reference doc. If we go here and we have a getting started, and then there is an example that you can basically copy. The problem is I want to have this working behind a proxy that we might see later, but you have to do some extra customization. So don't worry too much of what we see here. I will walk you through this quickly, but it's basically from the example from their website. So we have the so-called authorization server configuration. There is some things here that I copied from the website. We have the JW2 configuration, which basically configures our JWT. What we also need is what I called user client configuration. So we can configure our server here very easily. There are some properties that I invented. You can change this thing to your belongings, whatever you like. We have a base URI we can configure. We can configure clients by just having a list, OAuth proxy, and then the password, which is, of course, totally insecure. And we have just a bunch of users, also username and password. And this will be read by this guy. We have a so-called registered client repository that we need to configure. And this reads in our property here, walks over it, and then it creates clients in an in-memory client. And we also need to generate users with a user detail service, which basically walks over the users and creates an in-memory user details manager. If you take a look at the code later, you will see it's pretty easy stuff once it's there. What you should be aware of, however, that the Spring authorization server is rather strict. It's not allowed to use this. So this is the password here, to use this multiple times. So every client should have its unique password. Otherwise, you will get an exception. Nothing special here. You can grab this from the documentation, but now the but. There is a special customizer configuration here. And that's very important. So I really had a hard time to get this thing running at the first time, because what was not working was localhost. So you could just not do a call with localhost because you will get exceptions. And the problem was you don't get exceptions because you only get the exceptions if you set the log level to trace, which is very, very odd, honestly. But if you have trace, it will tell you localhost is not allowed. Please use IP 172. Oh, I will not spell it out. It's basically this, the best place home. So this would work. Yeah. And also, you will need to configure all the redirect URIs here. So different applications can have different redirect URIs. To be precise, the redirect URIs are of your client applications. They do not belong to the server. The server just needs to know them to know that these are valid URIs. It will do nothing. It will just validate if the redirect URIs are known to the server and then say, yeah, you can continue or not. That's basically it. It will just do a pattern matching. And I did the same what Keycloak can do here. You can just have an asterisk here, and then every redirect URI is allowed. So that's all the complete code we need here. That's from the documentation. We have the asterisk here where it returns. And if it's not an asterisk, it will check the redirect URI here. And in contrast to the original validator that was being used, it will not bail out if you use localhost. So that's a lot of code for so few changes. That's very important. What we also need to do is, which is also not nice. So the user detail service of Spring Security only knows about username and password. And it claims that it can do roles, but these roles are not compatible with OpenID Connect. So don't be fooled. This is only for standard Spring Security, and we need to manually add things that we want to have for the OpenID Connect part, which is, yeah, not nice, honestly. Fortunately, there was a web page that hinted into this direction. So for our proxy later, we need an email address. We also need a preferred username. We can get this from the principal. And we also might need to copy our roles, because the roles here are not the roles that we need inside our JWT. So, but that is not a lot of code. Take a look. You will see how this works. Also, Spring has the thing that it adds role underscore to every role, and we need to strip this. And then we have some additional configuration here where we can reconfigure some of the endpoints. But that's mostly it, and then the server will work. So there's one more thing that we can take a look at. While having OpenID Connect in Spring and Quarkus directly is a nice thing, it couples our applications with OpenID Connect. And as I showed you in my Kubernetes video, if you've seen this, it's also possible to do this by proxy. So let's take a final look at this. So what we need to do is first bring up our Spring Authorization server. It would also work with Keycloak, it doesn't matter. And bring up our application. So it's important to stress that this is the application, the Corley service, that is not implementing OpenID Connect because it's working by proxy. So what we now will get is a reverse proxy on one side and an OAuth proxy on the other side. Let's first take a look here. So I will open this. So it now tells me sign in with OpenID Connect. This is done by the OAuth proxy. Looks very similar like before, but it's very different. Ta-da, and we are logged in. But again, this is not part of the application. So what we are leveraging here is, if we take a look in our Docker Compose file, so this has the auth server, and this has also on the server side the OAuth proxy here that has a lot of configuration. You can take a look at this later. This is out of scope for this video. And then on the client side, we have a standard Nginx configuration. Very simple, but it has two includes. It has an include for sign in and for the proxy. And the important part, now I'm searching it again, is this auth request. So what it will do, it will put the OAuth proxy behind the reverse proxy. You will see this in this configuration. And then the OAuth request will be initiated every time you hit the application. Don't worry too much about this configuration. This is just copied from OAuth Proxy's website. Just take a look, and if you don't understand it, it's not a big deal. Just know that it's working, and just to have an easy idea how things are working here. And that's mostly it. And the nice thing is that with this, we can not only secure Spring applications and Quarkus applications, we can also secure Go or Python or everything, anything else. So thank you so much for joining this video today. I hope that we all learned something. I know it's a little bit complicated, but I really hope that it was possible to clarify some of the sticks and stones I fell over, and maybe this will help you along the way. And I hope to see you in the next video. Thank you and bye.